What's up, people? Welcome to today's session. My name is Anoop and this is Vedantu. I hope that all of you guys are doing good. And yes, people, here we are. Finally, we're going to be starting off with the VIP series, Vela Illa Pattatari series. Nah, it's very important problems. So we'll be solving some very important problems of all the chapters that we have of CBSE 10, starting with light. And in fact, we're going to be focusing on one particular topic in today's session, that is concave mirrors. We're going to be solving only problems related to concave mirror. We're going to be focusing on what type of questions, all the different types of questions, in fact every single type of question that can possibly appear in your board exams as well your pre-boards is what we're going to talk about from concave mirrors alone. A lot of the series that is going to come ahead of this will be pertaining to one particular topic alone. So next we'll be focusing on convex mirrors and so on and so forth. So make sure that you subscribe to the channel and also hit the like button as well, guys. And a very warm welcome to all of you guys out there. My name is Anoop and this once again is Vedantu. So concave mirror problems, let's get started without wasting any more time. Amazing 8 to 9 amazing questions is what I have in store for you people. From the most easiest questions, so some of the questions are in your sample papers, some of them have been chosen from board exams, some from pre-boards. So there's like a mix of all kinds of questions that you can expect with this. So make sure that you get your pens and paper ready and get started. Right? So here is your quote for the day, just to spark a little, just to give you a slight kick of the day so that you can get started, because I know that you guys are all lazy. It's a Sunday, I understand it, but still we have to work hard, people. We have 4 months left. Let's make it count, and then after that we can just chill out, right? So here's the quote for today. You can never cross the ocean until you have the courage to lose sight of the shore. What Christopher Columbus is indirectly trying to say is, don't play it safe, people. Take a little bit of risk in life. Maybe not regarding to your board exam. I'm not talking in with regards to your board exams alone. I'm talking about in life. You always should have the courage to take some risk. It's okay. You might go wrong here and there, but when will you learn? If you don't make mistakes, what's the point, right? So make mistakes. Have the courage to try out something new. And you never know, that might be something that you might fall in love with and you would want to take that forward as your career. You never know, right? So try it out, because you guys are young. So do that, people. With that said, let's start with the VIP question number 1. Like I told you, we have 8 amazing back-to-back okay, let me skip that. We get the point. Amazing questions. Alright, so here's the first one. What is the minimum number of rays required for locating the image formed by a concave mirror of an object? In other words, how many number of rays are required to form an image? Your options are 1 ray, 2 rays, 3 rays, or 4 rays. Now, let me know what is the answer of every single question in the comment section as well. So write down all the answers and put it up in the comment section, and I'll check out the comments and see how many players are able to give the right answer. Alright? But with me, pause the video and try to figure out the answer for this one. Now remember, people, in a concave, no matter what type of mirror it is, even if it's a concave, convex or plane mirror, it does not matter. You need at least, this is the principal axis, you need at least 2 rays of light to form an image. So the answer to this question, people, would be option number 2. You need at least 2 rays of light to form an image, and hence the right answer would be option number B. Simple, right? A very easy question, but it's a basic question. I hope, because this was asked in 2009 of your board exam. So yes, people, you can expect these kind of 1 mark, 2 mark questions as well. So it's a very simple question. Don't get it confused. You should not get it confused right now, right? By now, though, you should be fairly confident with all these. All right, second question. The image formed by a concave mirror is observed to be real, inverted, and that of the same size as that of the object. What should be the position of the image? Interesting. Remember your ray diagrams, people. Try to recollect your ray diagrams and let me know what is the answer. Your options are between focus and the center of curvature, at the center of curvature, between the pole and the focus, or beyond the center of curvature. What do you guys think? It should be a real image, it should be inverted, and also it should be of the same size. Which of the ray diagram do you think would satisfy that particular criteria? If you were to ask me if I were to draw it now, please ignore my, please Please give a little leniency on my ray diagrams, people, because I have a tendency to draw really bad. I'm a really hopeless artist. So yeah, if the object is kept at C, imagine one ray of light parallel to the principal axis goes and hits the mirror, boom, and then what will happen? It will pass through the focus, because any ray of light which is parallel to the principal axis will pass through the focus after reflection. That is one of the the principal rays we're talking about. Then we have one more ray of light that is passing through the focus after reflection. It will become parallel to the principal axis, and hence, where do you think it meets? People, where do you think it meets? It meets right at the focus. Now, like I told you, my diagrams are not as accurate as it should be, but yes, you get the point, people. So the answer should be that the object should be placed at C, at the center of curvature, so that the image can be of the same size, right? Using a simple ray diagram, an easy 2-mark question, and that's yours, right? Simple 1 mark, 2-mark questions, easily you can get it. If you are asked to draw the ray diagram, that will be as a 2-mark question. So that's 2 marks right there, people. Such an easy question. So remember your ray diagrams, super duper important. So right answer is that C, right? Third question, here's another one. If an incident ray passes through the focus of a concave mirror, the reflected ray will pass through the center of curvature, pass through the focus, be parallel to the principal axis, or be inclined to the principal axis at an angle greater than 0. What do you guys think? I just answered the question for this one, actually. So if you think about it, if this is a concave mirror, if the ray of light is passing through the focus, and after reflection, it will become parallel to the principal axis, because that's how it is. This is one of the principal rays, the principal incident ray. There are 3 principal incident rays. One is that if it's passing through the focus, then it will become parallel to the principal axis after reflection. The second one is if it's already parallel to the principal axis, then after reflection will pass through the focus. And thirdly, if a ray of light is passing through the center of curvature, then it will pass through undeviated. So that's how it is, people. So the right answer would be option number C. Simple, right? Moving on to the 4th question. Such easy peasy questions. I know you guys are wondering, sir, where are the difficult ones? Wait, hold on, it's coming. Here's the 4th one. The focal length of a concave mirror is given as 15 centimeter. An object is placed at 35 centimeters from the pole of the mirror. Find the what is the magnification M? Your options are positive and magnitude less than 1, negative and magnitude less than 1, positive and magnitude greater than 1, or negative and magnitude greater than 1. Alright, so let me write down the given data first. I don't think let me just write down the given data first, because I don't have an extra sheet. So let me just write over here itself. Okay, let me talk a little slow. Focus is given as 15 centimeter. First thing first. The object is placed at a distance of 15 centimeter. Now remember, people, in a concave mirror, the focus is also something which lies in front of the mirror. So it's going to be minus 15, alright? That's the first thing. Remember the sign convention. Never ever ignore that, alright? The object U is placed at a distance of 35 centimeter from the pole. Again, in front of the mirror. So be minus 35 centimeter. Done. Alright, you're supposed to find out what is the magnification. The formula for magnification is M is equal to minus V by U. I know the value of U, but I don't know what is V. So I'm going to use the mirror wala formula to find out what is V. So mirror is 1 by U plus 1 by V is equal to 1 by F. So I'm just going to write it over here. 1 by V plus 1 by minus 35 is equal to 1 by minus 15. So 1 by V is equal to 1 by minus 15 to the other side, minus 1 by minus 35, because once it goes to the other side, it will become minus again. So that is what, again, you can cross multiply, find out the LCM. So that's minus 35 plus 15 divided by cross multiplication again. That's 15 into 35, minus into minus will become plus. So 35 plus, wait a second, okay, I made a mistake. So guys, this minus and minus will become plus, so you can just directly write as plus itself over here. Why to make all this confusion? So that'll be plus, so it'll go there. Okay, minus, okay, wait, no. Okay, so that's okay, wait. All right, I think I made a mistake. I think I made a calculation mistake. All right, so plus, okay, minus 50. Okay, wait, let's just keep it as it is. I'm making some sign mistakes, people. please avoid it. Minus 35, right? So minus 35 goes to the other side. So minus 35, minus 15. Okay, yeah, minus 15. All right. So this will be what? 30, 15 into 35. All right, yeah, makes sense now. So it'll be minus 50 divided by 15 into 35, I believe is 525, if I'm not wrong, 525. So that is 1 by V. So V is equal to 525 divided by 50, 510 50, 510 50 again, 525. So V is equal to minus 10.5, right? 105 divided by 10, so minus 10.5, right? So that is your V. Now to find out the magnification, so I'm just going to write it over here itself. Okay, I think I can write it over here. Okay, so I'm just gonna make a partition. So M is equal to minus V by U minus of minus 10.5 divided by U here is minus 35. So if you divide this, I think you'll get it as 0.3. So here it is minus 0.3. In fact, you'll get it as minus 0.3. So what is the magnification? Magnification is less than 1. So it has to be option number 2. Then it has to be less than, okay, it can be either 1 or 2, but then because it's negative, we can say that it's option number 2, right? I hope I've done the calculation correct. I might have made some calculation errors, some sign errors, maybe just cross check it once, but I think so far what I've done is correct. But if I did make any mistakes, I'm really sorry. You can make that correction by yourself, simple mathematics. You can do it, and then let me know in the comment section if I've made any mistakes as well. So that is the answer, people. It'll be minus 10.5. that would be your image distance, and the magnification is going to be minus 0.3, and hence option number 2, right? That is the answer for the 4th question. That would be your first problem that you actually solved. Moving on to the 5th one, pretty much halfway through, people. This was a question asked in CBSE 2009, which is pretty much recent. So yes, go ahead and try to answer this question. Not pretty recent, okay, it's like 11 years ago, but still, here's the question. It is desired to obtain an erect image of an object using a concave mirror of focal length 20 centimeter. What should be the range of the distance of the object from the mirror? Will the image be bigger or smaller than that of the object? Beautiful question. Wow question. Okay, the question is this. You want to get a erect image of an object using a concave mirror. The focal length of the mirror is given as 20 centimeters. You're supposed to find out what range you should keep the object such a way that you are able to get an erect image, and also will the image be smaller or bigger than the object? I can directly tell the answer, but I would prefer by doing, by drawing the ray diagram. So this is your ray diagram. So you have the focal length is given as 20 centimeters. So this is F. So now in a concave mirror, remember, the only condition where you can get a erect image, a virtual image in a concave mirror is when the object is placed between the focus and the pole. Only in this condition you are going to get a virtual image. So you have to keep the object somewhere over here. So if the object is kept over here, one ray of light parallel to the principal axis after reflection will pass through the focus. One more ray of light will go and hit the pole, and it will go away from the other ray. So this is your ray diagram. This is what it would look like. So again, it would appear to meet at this point. We'll just call this as A. I will just call this A dash or something. That is the only condition that you're going to get a virtual image, and hence the object should be placed between 0 to 20 centimeters. And if you look at the height of the object and the height of the image is much more larger than that of the object, and hence it's going to be much more bigger than that of the object. And secondly, the object has to be kept between 0 to 20 centimeters, that is within the focal length. Between the focal length and the pole is where you have to keep the object, right? Beautiful question, guys. I love this question. So that would be your answer for this one. Here is your ray diagram. If I've made any mistakes, again, if I made if the lines are not straight or something, please ignore it, because it's very hard to do it on this. So yeah, you get the point, people. So that's the answer for this one. So the range should be 0 to 20 centimeters, and if you're asked the ray diagram, that would be easy 3-mark question. So around you can get those 3 marks in your bag, and then you have the image that is bigger than the object. You don't have to even remember it. You can just draw the ray diagram. You can easily clearly see that the height of the image is greater than the height of the object. Simple. Moving on to the next question, guys. Here is your next question, the sixth question. Rays from the sun converge at a point 15 centimeters in front of a concave mirror. Where should an object be placed so that the size of the image is equal to the size of the object? One more super awesome wonderjustic, blunderjustic question. Your options are 15 centimeters in front of the mirror, 30 centimeters in front of the mirror, between 50 centimeters and 30 centimeters in front of the mirror, more than 30 centimeters in front of the mirror. Okay, awesome. Ray diagram, sample paper question. Okay, this is your concave mirror. You have your principal axis. So the question is, all right, the rays from the sun converge. Now, sun is a very distant object, all right? It's millions of kilometers away, several light years away, so it's very, very far away. So the rays of light that is coming from that sun is obviously, you can consider that the object is at infinity. Yeah, obviously it's very, very far away, so we'll consider the object is coming from infinity. The light rays are coming from infinity. If the light rays are coming from infinity, after our reflection, they will end up meeting at the focus. That's how it is, because they're parallel to the principal axis, so they will meet at the focus. So this 15 centimeters would then be the focus or the focal length of this particular mirror. So this 15 centimeters is what? The focal length, f. It is nothing but f. That is the focal length. Now, where should an object be placed so that the size of the image is equal to the size of the object? When is that condition? That condition is met when the object is placed exactly at the center of curvature. When the object is placed at the center of curvature, that is when you can say that the size of the image and the size of the object, or the height of the image and the height of the object is going to be the same. Now, the center of curvature, or the radius of curvature, you may call it as radius of curvature, center of curvature is nothing but 2f. It's nothing but twice that of the focal length. So what would be the radius of curvature then? It'll be 2 into 15, which is nothing but 30 centimeter. So where should the object be placed at? It should be placed exactly at 30 centimeter so that you can get the image which would apparently be of the same size as that of the object, right? So you can call that the center of curvature, or you can call it as the radius of curvature. It's pretty much the same thing. So yeah, you'll get the answer as option number what? Option number 2. So 30 centimeter in front of the mirror. One more super amazing question. I hope that you found that fascinating, because when I read this question for the very first time long ago, I found this question very, very fascinating. So yes, I hope that you guys also found that fascinating. Now people, if you want to have more such amazing sessions, you want to practice more, get better every single day, practice with the best of the best teachers and do your very, very best. All you gotta do is click on the link that is given in the description as well as in the pinned comment section as well. You are going to open an opportunity where you have the chance to learn with the best of the best teachers on the best of the best online platform, where you have this kind of amazing questions in every single session. Let me tell you what are the advantages of studying at Vedantu. First thing first, people, you have unlimited access to live sessions. How many ever live sessions do you want? You have the opportunity to just open up the app on the website or on the phone and watch how many ever live sessions you want in that particular day. You want to go ahead and watch 20 sessions? Totally up to you guys. You want to do 30 sessions? Up to you. 50 sessions? It's totally up to you. Obviously, it's not physically possible, but yes, no matter how many ever number of sessions you want, you can actually do that. And more importantly, each and every one of these sessions is going to be fun-filled session where you have the opportunity to interact with your friends as well as the teacher, and you also have the opportunity to take part in the quiz in every single session. And these quizzes, trust me guys, are one of the best quiz questions that you can get. You have a leaderboard, you have the fastest fingers list, the whole package is what you're gonna get. And with this as an added bonus, you also get to compete with the rest of the world and see where you're really at, what is your place. That is something that you can figure out by taking part in all of these quizzes. With this, even if you miss out a session, because guys, live sessions are going on 24/7 and it's not possible for a person, it's not humanly possible to attend every single session. So you might miss out a couple of sessions. Don't worry, even if you miss out a session, you have the interactive replay where you can take part in the quiz even after the session is done, and also check out the leaderboards, and at the same time study with a very interactive, or a very interactive platform. With all of these, you can download all the premium content of every single session, all the handwritten notes, whatever it is that is written on the board, even if it's a dot or a dash or a hyphen or a comma, whatever it is, everything would be recorded, and you can actually access that and go through it how many ever number of times you want. With this people, you also have the class teacher inside the session. Now you might be able to say, what is a class teacher? People, inside the session, you will not just have one teacher. No, you will have the master teacher obviously to teach you the concept, but together with the master teacher, you will also have someone called as a class teacher to help you clear every single doubt of yours. So it's a combined class wherein you have the class teacher and the master teacher helping together to clear every single doubt of yours. And as you guys know, you have 4 months left for your exams, so this is the time for you to start revising. This is the time for you to start practicing those tests and assignments. So you have that opportunity to practice unlimited number of tests and assignments and check where you're at. And based on these tests and assignments, you will also be getting a detailed report card of every single session, of every single tests and assignments you have taken, and that will give you an idea of where you've gone wrong and what things you can do to improve yourself as well. With all of these, yeah, I'm not done yet, people. 5,000 plus micro courses and crash courses, all for free. All you gotta do is click on the link that is given in the description as well as in the pinned comment section. You're getting a ton more, a lot more, lots of amazing stuff for a lot less. Again, you have to click on the link and enter the coupon code. Click on the fact that you have a coupon code and enter the coupon code AMEPRO to avail those discounts. Because if you go for the 1 month program, the base price of that is around 2,699. But if you use the coupon code AMEPRO, you get a discount of about 500 rupees, and the price comes down to 2,159 rupees. I know that it seems like a big amount, but I'll tell you, just give me 1 second, guys. I'll tell you how actually viable and how in fact how cheap this particular program is. If you go for the 3 month program, that's about 6,999. If you use the coupon code AMEPRO, you get a discount of 1,400, and what you're essentially paying for those 3 months is 5,599. And if you're planning to take it up, guys, go for the 3 month program because it saves a lot of money, and on top of that, you also have the access for all the live sessions for the next 3 months, which would definitely help you boost up your performance in your board exams. Because I know that a lot of you guys are scared and are wondering what to do next. Now think about it, guys. In that 1 month duration, in that 30 days, you would have attended a minimum of 200 sessions, a bare minimum of 200 sessions. That means that per session you're paying about 11 rupees. That is 2,159 divided by 11 by 200. That's about 11 rupees per session. And if you go for the 3 month program, like I told you, it's going to be much more less than that, which is going to make the price to be about 9 rupees per session. And most importantly, guys, I would say that you have the best of the best teachers of the country helping you guys out to make sure that you guys ace your exams. Now think about this price, 11 rupees, 9 rupees per session. That's less than what you spend on simple a packet of Lays, which is like 20 rupees, and it lasts for like what, 5 minutes, 10 minutes at the most. But this is for your own future, this is for your own education. So yeah, think about it. The link is given in the description. The coupon code is AMEPRO. So the 7th question, again a sample paper wala question. The question is this: a concave mirror produces 3 times enlarged image of that of an object placed 10 centimeters in front of it. Calculate the radius of curvature of the mirror and assume that the image is virtual and erect. Let's go, people. Such an easy question. Your options are minus 30 centimeters, minus 20 centimeters, 15 centimeters, or 10 centimeters. Go ahead and do it. I'll also do it with you, but yeah, you have to solve it with me. Sit and do it with me, people. So first of all, okay, the magnification is given as 3 times the image. So M is nothing but 3. They've also given the object distance. The enlarged object, the object is kept at U is equal to minus 10 centimeters. Find out what is the radius of curvature. So first of all, find out what is V. So M is equal to minus V by U. So M is 3. 3 is equal to V minus V divided by minus 10. So that's minus 30 is equal to minus V. which is nothing but V is equal to 30 centimeters. Simple. Found out V. Once you find out V, then use the what to say, mirror wala formula. 1 by V plus 1 by U is equal to 1 by F. So 1 by V is 1 by 30 plus 1 by minus 10 is equal to 1 by F. So I can write this as 1 by 30 minus 1 by 10 is equal to 1 by F, just to avoid confusion, sign wala confusion. So that would make it into 3. So that's 1 minus 3 divided by 30 is equal to 1 by F. So that's minus 2 divided by 30 is equal to 1 by F. So F is equal to the reciprocal of that 30 divided by minus 2. So that's 15 minus 15 centimeters. So F is equal to minus 15 centimeters. Now to find out the radius of curvature, simple. Radius of curvature is 2 times the focal length. So 2 into minus 15, that's minus 30 centimeter. That would be the answer, people. So the right answer would be minus 30 centimeter, which is nothing but option number A. I hope you guys got it, because it is something that you should have been able to solve without any sort of assistance. So that would be the answer for this question, guys. Moving on to the 8th question, the finale, 2008 CBSE wala question. Here's the question, guys. An object of 2 centimeters in size is placed 30 centimeters in front of a concave mirror of focal length 15 centimeters. At what distance from the mirror should a screen be placed in order to obtain a sharp image, and what will be the nature of the image? Nature and the size of the image formed. So your options are V is equal to minus 60 centimeters, V is equal to minus 30 centimeters, V is equal to 20 centimeters, or V is equal to 410 centimeters. My God. Alright, so let's try to do this, people. So H is given. First of all, the height of the object is given as 2 centimeters. That's done. The object is placed at a distance of 30 centimeters. So U is equal to minus 30 centimeter. They've also given us the focal length F is equal to minus 15 centimeter, because again it's a concave mirror, so focal length would be on the same side. So minus 15 centimeter. At what distance? So V is what you're supposed to find out first. So 1 by V plus 1 by U is equal to 1 by F. So 1 by V plus 1 by minus 30 is equal to 1 by minus 15. So 1 by V is equal to 1 by minus 15 minus of 1 by minus 30. So I'll just take that outside, so it'll be plus. So that'll be what I can write this as 1 by 15 minus 15 plus 1 by 30. All right, now to simplify it into 2, so that's minus 2 plus 1 whole divided by 30. That is what you're going to get. So you have minus 1 divided by 30. So V is equal to what? V is equal to minus 30 centimeter. I'm guessing that would be the answer for this question. So that is an option. So V is equal to minus 30 centimeter. So yeah, we got that. But the question is not done yet. They're asking you to find out the nature and the size of the image as well. So for that, use the magnification formula. M is equal to minus V by U. So minus of minus 30 whole divided by minus 30 again. So minus gets cancelled. So you'll get it as minus 1. So because it's minus 1, that means that the image is going to be of the same size. It'll be of the same size, and it's because it's minus, it's going to be an inverted image, and inverted images are real as well. So these are the nature and the size of the image. The image is of the same size, it's going to be inverted, and it's going to be real as well. And if you want to draw the ray diagram, this is what the ray diagram would look like, because the object is kept exactly at the center of curvature itself. So that is the answer, guys. Minus 30 centimeter is your image distance, and this would be your nature of the image as well. That is it, people. That is it, and this is your homework for today. Let me know what is the answer by the start of the next session. So it's a Sunday. Solve it. Let me know what is the answer in the comment section. The question is this, guys. Find the nature and position of the image formed when an object of 1 centimeter size is placed at a distance of 15 centimeters from a concave mirror of focal length 10 centimeter. Repeating the question. Find the nature and position of an image formed when an object of 1 centimeter size is placed at a distance of 15 centimeters from a concave mirror of focal length 10 centimeter. Let me know what is the answer in the comment section. That is it from my side. Once again, the episode 2 of VIP series Vela Illa Pattadari. Yeah, very important problems. Convex mirror problems would be coming up next, so make sure that you subscribe to the channel and hit that bell notification as well, so you're aware of this of the session that comes ahead. And also, people, the link to join the Vedantu subscription course is given in the description as well as in the pinned comment section. Now the seats are filling up really fast, so do not miss out on the opportunity and try to grab it and make it yours. So that's pretty much it from my side. Thank you for being a patient viewer of this particular session. Thank you for joining. I'll see you guys in the next one. Take care of yourself. Catch you guys in the next one. Peace out, people. Bye bye. Good night, guys. Take care.